Let's look the first of a couple of exam questions about motion graphs for constant acceleration. The first one is this one. It's from Spring 2010 exam. That's paper 41, question 2. And the question is this. You have this graph, and it says the diagram shows the velocity time graph for the motion of a machine's cutting tool. The graph consists of 5 straight line segments. The tool moves forward for 8 seconds while cutting and then takes 3 seconds to return to its starting position. Find, first the acceleration of the tool during the first 2 seconds of the motion, over here, and then the distance the tool moves forward while cutting, and then there is a 3, the greatest speed of the tool during the return to its starting position. Okay, simple enough. I reproduce here a little sketch of, no, it's not this one, it's this. A little sketch of the graph. The first one, you want the acceleration in the first 2 seconds. So what you have, it's a velocity time graph. The acceleration is given by the gradient of the line. You have all the information required here. The change of height, that's 0.18 minus 0, over the change of distance, so to speak, the base of the triangle, so 2 minus 0, that's basically just 2. So this is 0.09 meters per second square. Velocity is meters per second, time in seconds, so meters per second square. Then you wanted the distance the tool moves. The distance the tool moves forward while cutting. So the tool is moving forward on the first 8 seconds of motion. So you need this area over here. What is this shape? This is a trapezium. The area of the trapezium is the smallest side plus the biggest side, the ones that are parallel, times the distance between them, divided by 2. This is 8. The height or the distance between them is 0.18. You don't know this. Yes, you do. You have here this distance is 6 minus 2, so you have everything that you need. 4 plus 8 times 0.18 divided by 2, that's 1.08 meters. Look, you have here 2 questions in which you just have to, it's a one-step answer, and you have a total of what? Okay, basically 3 points. Then the greatest speed of the tool during the return to its starting position. The key information on this one is that it starts to its original position. So whatever the distance it traveled over here, which you already know as being 1.8 meters, is the same that the tool is going to travel as it goes back. So what you know that the area of this triangle is also 1.08 meters. And you'll use that to calculate the value of V. Because in order for you to get the area of the triangle, you need the base, which you already have. It's 11 minus 8. And the only thing that you are missing is the height. But that's exactly what you need. Right? So the area of the triangle is I'm sorry. The area of the triangle, it's 3v over 2. Why 3v over 2? Let me see. Oh, of course, the 3 comes from the base over here. Base times height divided by 2. So 3 times the height, which is V, divided by 2. The formula for the area of a triangle equals 1.08. All right. So the V equals this times 2 divided by 3, which is 0.72 meters per second. Okay. That is the value of V. Another question. This is a paper 4 from October, November 2008. Question 6 over here. A train travels from A to B, a distance of 20,000 meters, taking 1,000 seconds. The journey has 3 stages. In the first stage, the train starts from rest at A and accelerates uniformly until its speed is v meters per second. In the second stage, the train travels at constant speed v meters per second for 600 seconds. And during the third stage, during the third stage of the journey, the train decelerates uniformly, coming to rest at B. You need first to sketch the velocity time graph for the train's journey. So you have a constant acceleration, constant speed, constant deceleration. Basically, the shape is going to be something like this. All right. You know that this time over here, while it is moving at constant speed, this is 600 seconds, but you don't know when this starts and when this ends. You just need that the total distance takes 1,000 seconds, and that's what you put over here. You also don't know yet what this velocity, this constant velocity is. But next question, find the value of v. All right. In order for you to find the value of b, you need to use the fact that you know the total distance. It tells you it was 20,000 meters. So you use the formula of this shape, the area of this shape, which is a trapezium. So smaller side plus bigger side times the distance between them divided by 2. You know this is 600, right? You know this is 1,000. The only thing that you do not know is v, right? So rearrange the formula and you'll get the value of v as being 25 meters per second. So now you know another thing, v. More. Given that the acceleration of the train during the first stage of the journey is 0.15 meters per second square, find the distance traveled by the train during the third stage of the journey. Okay, what you need to know? You need to know this distance over here, right? In order for you to calculate this distance, you need to know the height, which you already know, it's 25, but you need to know this. You know that this is 1,000, but you don't know what T2 is, right? You don't know what T2 is, and what information are you being given? It's the acceleration, but the initial acceleration. This one over here. So what does this have to do with that? Well, with this, you can calculate what? You can calculate this time, right? And once you know this time, you add 600 and you get this time. And once you know this, the base is 1,000 minus it, all right? So let's calculate that first. The acceleration is v minus u over a, so basically the gradient of that. So rearranging this, u is 0. So, sorry, rearranging this, u is 0. So the t is going to be v minus u over a. So 25 minus 0 over 0.15, right? And this is 167 seconds. So you already know this. So it takes 600 seconds while it is moving at constant speed. So right now, what time is it? 600 plus 167, so it's 767. So the base of the triangle that will yield you the area and thus the distance that you want is 1,000 minus that times the speed, which is 25, divided by 2. And this gives a value of 2,920 meters, correct to 3 significant figures. Okay, simple enough.